Hey guys, and welcome to the coding challenge for February. This one is called the isomorphic string question. Let's quickly go through the question first, and then we'll go through our solutions and then a simple explanation. So you're basically given two strings. So imagine we're given S and T as foo and bar. The isomorphic, if we can basically do the following. So if I kind of write foo here and then bar here. So imagine we basically say we want to transform foo to the word bar. So what we do is we transform F into B, O into, O into A. But because we've already done O into A, this last section here, where we transform O into R, this basically means like, no, we can't do this. Basically means like every letter has to map correctly. So if the string looks like that, it'll be okay. F goes to B, O goes to A, no problem at all. But it's when we have like a situation like this, so O and R here, O has already been mapped to A, we then can't map it to R. So in this case, this would be, no, it's not isomorphic. Whereas with paper and title, if you see where we've got the two P's, we have P at index 0 and 1 and 2. Yeah, so 0 and 2. We then have a T in 0, 2 as well. The rest of them are then like unique. So yeah, this would be true. This would be false. Let's zoom out ever so slightly. Let's clear the screen. And we'll go through our first submission. So cheers, Dan. Thanks for this. This is really nice. Dan sent this over email. Of course, if you do want to email me your submissions, I'm more than happy to accept them. If you go to the About tab, my email address is there. So you've got a nicely written function with this nice doc string here. Pretty cool. I like this. And we've imported the counter function from the collections module. So let's go through your code. So you've set up smap using some nice fancy type annotations here. So smap and tmap, these are dictionaries with strings for keys and integers for values. So you've done counter of S, counter of T. And then you've done S counts and T counts. Okay, I see. Yes, you've made a frequency table for each, and you've then done sorted values and tmap.values here. Okay, so it looks like you're sorting the list of frequencies to ensure they're matched up properly, and then returning it here. So I'm going to try this with, bear in mind I've just got the two edge cases, but we should see false true. Okay, cool, nice, looks good. So once again, yeah, cheers for submitting that one, that's really nice, and I particularly love these type-ins as well. Now our next submission, this is from Ross K. Graham. I think you've submitted a few, so yeah, cheers, I very much appreciate that. Your code is always nice and simple, straightforward, easy to read, so yeah, very much appreciated. And this also looks really nice, so let's see what we've got. We have your function is isomorphic, you're accepting S and T. This is nice actually, this little check at the top. So straight away you're going to say, okay, if the lengths don't match, then return false. Yeah, that's a great idea, I really like that. You've then gone for a dictionary in the same style as the previous. So again, using your type annotations. Looks good. Okay, I'm going to quickly run your code. I'm going to just take these for a second and add these to my print statement here. So just to kind of get a sense of what's going on, actually, yeah, it would help if I called your function, wouldn't it? You can tell it's the weekend. Okay, so we're going through EF, GO, GD. Now then, you've got some kind of fancy check going on here. So we've got an and statement, and we've got this. So let's go through it from left to right. So if mapped characters.get, S character. So, okay, yeah. So basically checking like, you know, if something is returned in the first place. So this .get, if this isn't in the dictionary, this is going to return none. None equates to false. So yeah, it has to be there in the first place for this second check to then kind of, you know, take precedence and be checked also. And then mapped characters.get S character equals T character. Oh, that's interesting. So let's take a look at this. So the first section we come to is E and F. There's nothing there in the dictionary yet, so nothing can really happen. But what you then do is you then add it for the next check. So if we then do G and O, at this case you've only got E and F in your dictionary. Okay, looks good. And then, so yours is going to fail on this one. Will fail as in like return false. So in this next run, you're going to have EF and then GO inside your dictionary. So the next one after that is then going to be checking G and D. So that's going to be this here. So when we're saying GD, you're basically going to be saying like, okay, is G in the dictionary? It is. Okay, so is the mapped character for S the same as T? So mapped characters.get. That's cool, yeah. So basically you're checking like effectively just O match D. And because they don't match, it's false. Oh, that's nice. Yeah, that's a nice way of kind of looking up the mapping from each word. Nice. I think that's really smart. Yeah, I like that one. Cheers for submitting that. Let's quickly test it with this. I'm sure it's going to work. Let's give it a try. And then you get true. Yeah, I think that's a really neat, simple solution as well. And I think because you're using a dictionary as well, it means that these lookups are really quick. So yeah, nice, cool, simple, smart, linear, time-solvable solution. Cheers. Just to round the video off, let me go through a simple way of doing this as well. If I take... let's grab these here, paper and title. Bring these downstairs. So S is paper and T is title here. I'll run you through a nice simple way you can do this as well, just kind of outside of a function. Let's call this one map A. So you're going to be an empty list here. And I'll just do kind of one run through just with this single string here first and go through. So if I say for I in S here, map A dot append, and let me just try something. I'm going to do S dot index of I here. And then we're also then going to take this and repeat it for B as well. Or sorry, T I should say, but we'll call it map B instead. And then we'll just switch this out for T dot index of I. And then this is going to be map A. And underneath we'll then change map A to map B. And then, oh yeah, let's change this to map B. Make sure we're actually heading to the right thing. There we go. Okay, so here's a nice sort of simple way we can do this. So if we maintain an empty list, we can say, first of all, go through paper, and then append the following. So s.index of I, it's basically going to say, from the string of S, what is the first index that I appears? So think of P, that's going to first appear at index 0. Okay, yeah, cool. Then on to A, index 1, P again, index 0. So basically, like it's kind of monitoring the positions of the various letters within the string here. So in this case, paper and title, they kind of have the same like structures in like P and T are in the same place. Yeah, so same place here, same place here. I don't know, imagine if I change title to like, let's do that. So see how like it's 0, 0, 1, 1, 0, 2. So this now means it's not isomorphic. So just one kind of simple way you could do it, and then what you could do is you could do map B, and this would be your like actual check at the end here. So this should now be false, yeah. Whereas then if we change this back to title, this should now be true. Yeah, I think to be honest, there's a ton of ways you could solve this. If you've got your own solutions, or if you think you've got a nice kind of cool way of solving this, feel free to ping it in the comments. And of course, guys, I will be posting the March question fairly soon as well. So make sure you keep your eyes peeled on the community tab. I'll be posting, I think, probably a trickier question for March. And of course, if you've got any kind of ideas or questions as well, feel free to also send those in. Cheers, guys, and have a great rest of your weekend.